Hey everybody, this is a tutorial on how to do some of the concept builders coming up on May 6th, the day I'm out. Hopefully this helps you out. Basically gonna speed run the three harder ones here and go through how to do them just to get you guys on track in case you need some help with that. So, you guys, we talked about yesterday node, antinode, and antinode constraints on what kind of a standing wave or harmonic can get set up inside a certain space. The one with the node antinode is a little different than the other two. So we're going to leave closed and air columns for last. And I left some notes right in Google Classroom here for you guys to check out too. So let's start out with the standing wave on a string. That's the same one we started with, well, today as I'm recording this, or yesterday, the day before, if not. So loading that up. Oops, I guess I already did that. Here, standing waves in a string. So starting out, let's try the beginning level. So you guys might recall a standing wave in a string. It's got a node on one end, it's got a node on the other end, and there's different patterns you can set up in between, starting out from very simple to slightly more complicated. The very simplest one is called the first harmonic, also called the fundamental, and it looks like this. That is a first harmonic pattern I'm showing right here. Each successively more complicated pattern is going to include kind of more of a wavelength within the constraints of that space. And this right here is a great example of the third one. A second harmonic would have only gotten to here. The third harmonic keeps going. It's now 1.5 wavelengths. So just jumping over, let's just model this real quick one more time in case you just want to recap from yesterday. So if I have a node and a node, simplest shape I can put in that follows those constraints, a standing wave, a harmonic, looks like this. And this is 1/2 of a wavelength fitting in between whatever that distance is. Next one I could put in there, a little more complicated. This is harmonic number 2, also called the first overtone. And that is now a complete wavelength. I'm going to write it as a 2/2, just so we see the obviousness of this number series coming up here. Third harmonic, that was the one that the concept builder started us out on, would be the next one after that. And 3/2 of a harmonic fit in whatever distance this is. And so this was harmonic 1, this is harmonic 2, and this is harmonic 3. Also called fundamental, first overtone, second overtone. Okay, so this is standing waves in a string, real quick tutorial. Let's jump back over here. And so we are good on this first one. Third harmonic is that third most pattern. I'm gonna start to speed run here for a sec. Oops, mouse is over there. Here we go. All right. Now, this time they're asking for a fifth harmonic. So what I'm expecting to see is 5/2 of a wavelength. There's a half, 1, 1.5, 2, 2.5. That would get us to 5. We should stop right about here. How's that? 1, 2, 3, 4, 5. Yep. All right, now we're looking for the first harmonic. Simplest possible one. Boom. What? Oh, I flubbed that last one. Oh my goodness. Counting too fast. This is no speed run. Okay, that's way too many for fourth harmonic. There we go. 1, 2, 3, 4. Okay, sixth harmonic. 1, 2, 3, 4, 5, 6, 7. Nope. Nope. 1, 2, 3, 4, 5. Nope. 1, 2, 3, 4, 5, 6. Yep, that's 6/2 of a wavelength, or three complete cycles. That should match up. Now we're looking at second harmonic. That should be 1 complete wavelength. So hopefully getting the hang of this pretty quickly here. Should blow through this first level pretty easily. Let's check out level 2, starts to get a little more interesting. Okay, they're telling me the harmonic is 80 Hertz, but they want us to find the one that has 560 Hertz frequency. So 80 compared to 560, that is 7 times higher frequency, which means we need 7 times shorter wavelength fitting in between this endpoint and this endpoint of the string right there. So I think I'm looking for the 7th harmonic. 1, 2, 3, 4, 5, 6, 7, boom. Okay, so I'm looking at the frequency ratio between the fundamental and the harmonic you're asking about. Okay, so this picture right, actually they didn't even give us first harmonic as an option. Okay, if the basic is 60 Hertz, this is half the wavelength, this would be double that frequency. This would have 120 Hertz frequency. They want the one with 300 Hertz. That's 5 times bigger than 60. I need the 5th harmonic. All right, I'm gonna switch to speed running. So math in my head is just what's the multiple from the harmonic they want down to the fundamental they told me about. And then I'm finding that number of half wavelengths as a pattern within this. Oh, mosquito. Okay. Now, last one gets really interesting. So this string is 60 centimeters long, but the wavelength is only 40 centimeters long. So from here to here is 60. I want my wavelength to end right here. Hey, check it out. That must be 20. That's another 20. I'm at 40 now. And that means this is the third harmonic fits in this. Okay, so they're telling me how long the string is. They're telling me how long a wavelength should be, and I have to figure out how many wavelengths or which harmonic series fits into that space. Okay, so string is 48 centimeters long, and the wavelength gets me halfway across that string. Boom, there we go. See how that's one complete wavelength, gets me halfway across, 24 centimeters over, across that 48 centimeter long string. Okay, string is 64. Ooh, wait, harmonic is longer than the string. I almost flubbed this. Okay, this is 64 centimeters. I would need to keep going another 64 to get to that spot right there. That would be over at 128. So in this case, the wavelength is longer than the string. It must be the first harmonic there. That's a good one. Okay, that's 80. 32 would get me to about here. Oh, there we go. So this gets me to 32. This gets me to 64. Remaining half wavelength is 16 more. Okay. So that was wavelengths on a string. They're defined by nodes at both ends. Let's check out open-ended air columns. It's going to be real similar, except we're going to have antinodes at each end instead of nodes at each end. So let's just redraw this with antinodes. So I could be at either antinode at each end. Kind of that's the middle of the graph right there. Simplest thing I can do is connect like that, which would look like that once it flip-flops. And that is half a wavelength, because I'd have to complete the wavelength on over here. So for harmonic 1, it is a half wavelength fits in that space. Second one would have to do that, which when it flip-flops would look like that. That is harmonic 2, which is 2 halves of a wavelength. In other words, we completed an entire cycle. And then here we'll do the third one in the series. And now we have complete wavelength to here and an additional half wavelength here. So 3 halves of wavelength rounds out the third harmonic, and that pattern keeps going. So this pattern is really not that different than the ones with nodes at each end. It's just completely flip-flopped. It's offset. It's out of phase with the thing that came before that we talked about earlier. So they're looking for the 6th harmonic. 1, 2, 3, 4, 5. Nope. 1, 2, 3, 4, 5, 6. Yep. Boom, easy. Second harmonic, 1, 2. That's what I'm looking for, okay? 1, 2. Second simplest pattern I could fit between antinodes. Just counting my way across antinodes. First harmonic, yep, that's the simplest thing I could possibly do. Also has the longest wavelength and therefore the lowest frequency. All right, third harmonic, 1, 2, nope. 1, 2, 3, yep. Fourth harmonic, 1, 2, 3, 4. That's what I'm looking for. 1, 2, 3, 4. There we go. All right, fifth harmonic, 1, 2, 3, 4, 5. 3, 4, 5. Yep. Okay, so first level, breeze through it. Second level is kind of the same. The first harmonic's 120. Which one would get me 360? 1, 2. That would be a 240. 120, 240, 360. We're looking for the third harmonic, a multiple of 3 over the frequency of the fundamental, which will also have 1/3 the wavelength compared to the fundamental. All right, so 80 to 480, the factor of 6. Be a pretty dense wave. 1, 2, 3, 4, 5. Nope, too dense. 1, 2, 3, 4, 5. No. There we go. 1, 2, 3, 4, 5, 6. All right, you guys get the point. I won't do all these. Let's jump back and look at the last level. Okay, the column is 48 centimeters long, but we have a wavelength that's longer than that. So this would be 48 centimeters from side to side. I'd have to keep going to complete the wavelength on over to here. That's the one we want. Okay, 48 centimeters gets me to here. 32 centimeters, let's see, one. Let's see, there's 16, there's 32. Oh yeah, that's a wavelength of 32. And that leaves me 16 more to get halfway through the second cycle. Yeah, that matches. Right. We need to have 2 complete waves finish by the time we cover 64 centimeters. 1, 2, boom. Okay, 80 centimeters. We need to have 2.5 waves. You know, 32, then 64, and then 16 more after that. So that's a lot of waves. 1, 2. That's not it yet. Okay, there's 32. There's 64. There's 16 more. 2.5 wavelengths fit inside 80 centimeters. All right. Now we're going to go to the last one. Yeah, we'll come back to that later. The one with the closed-end air column is a little trickier. And let's take a look why and kind of go ahead and map that out. So you guys can see at the left side, we've got a node. At the right side, we've got an antinode. That's the general pattern all these are going to follow. Go ahead and make that harmonic series again. So I'm going to put a node at the left and an antinode at the right. And the simplest thing I can do is that, which would flip over to that. And that is only 1/4 of the wave. Like it would come back down, and it would keep going, then it would keep going. This is the first harmonic is only 1/4 of a wavelength. The second time I did this, I'd go up, down, and back. And what I haven't finished is this piece right to here, or this piece to here. So I've got 3/4 of the wave. You know, here's half of it, and here's another 1/4 of it, and I'm missing that last 1/4. So this is going to be 3/4 of a wave. Now, this is the second harmonic in this pattern, right? But for whatever reason, we named this the third harmonic. Okay, we're skipping evens. There is no second harmonic in this series. We're skipping, we're just counting odds here. That's the tricky thing that might throw you guys off from the other two. There's the third one. I'm not going to call it the third one though. I'm going to call it the fifth one. Harmonic number 5, and it is 5/4 of a wavelength. You're like, okay, I could see why they name them 1, 3, 5. It's because we had 1/4, 3/4, 5/4, etc. We're kind of counting up by odds. So with that in mind, this last one won't stump you. It should be fine. Oops, can you guys see the prompt on this? Tap on the diagram, tell me. What is it asking? Oh, there we go. I hope that wasn't scrolled out for you guys earlier. Okay, 7th harmonic. So I'm looking at 1, 3, 5, 7. I want to end on this thing. 1, 3, 5. 1, 3, 5, 7. No. 1, 3, 5, 7. I'm counting by odds this time instead of counting by all of them. All right, 9th harmonic. 1st, 3rd, 5th, 7th, 9th. Pretty close. 1st, 3rd, 5th, 7th. Nope. Oh, hey, why was that a nope? Let's go back. That was a nope because it ended on a node. The open end has to end on an antinode. Okay, let's keep going. 1st, 3rd, 5th. 1st, 3rd, 5th, 7th, 9th. Boom. Okay, hopefully you get that. Let's jump to the next level. Okay, so 1/4 wavelength. Oh, wait. So 1/4 wavelength equals 80. So when this whole thing is filled up, that's equivalent to, oh, they didn't even show us that one. So 1/4 gets us to 80. What multiple of that is this? That's 9 times 80 makes 720, right? So we're looking for the 9th harmonic. First, third, fifth, seventh. Can't end on a node. Nope, nope. Okay. First, third, fifth, seventh, ninth. Boom. Okay, so we looked at the multiple of the fundamental up to the harmonic times 9. Looking for the 9th harmonic. So hey, that naming system works out great as far as how you think this through. Okay, 100 is the fundamental. 700 is the harmonic we want. That's the 7th harmonic in this series. So 1, 3, 5, 7. Yep. Okay, 100 up to 500. 1, 3, 5. Almost done here. 60 to 180 is a times 3. 1, 3. Whoa, some funky music. Okay, last level. So, the column is 24 centimeters long. We need a harmonic with a wavelength of 32. What I'm hearing is that the wave is slightly longer than the tube. This wave finishes inside the tube. We need a wave that doesn't finish until after the tube is done. So how about that one? Okay, so if this gets me, let's see. This gets me to 8. That would get me to 16. That would get me to 24. Yep, I'm at the end of the pipe now. The wave's not finished until we get to 32 right about here. That matches this 3/4 of a wave fits in the pipe profile. That the pipe is shorter than the wavelength? That's correct. This third level might take a little more thinking. Okay, so the pipe is 25 centimeters long. A wavelength is a little bit shorter than the pipe. That's the one. See how we get to 5, 10, 15, 20? We're done with the wave. They said the wavelength is 20. Perfect. We have 5 more to go, a quarter wavelength to finish and end up at the length of the pipe. That 20 takes up, most of the 25. We have a little bit extra sticking out. I don't know if that thought process is helping you or not. If the math just clicks, just go with the math. That's fine too. Ooh. This wave is 4 times longer than the pipe is. We're only going to have a quarter wavelength fit inside there. All right, and this wave is quite a bit shorter than the pipe is. So we're going to have less than 2 waves finish. How about this? Here's the first wave. Here's most of the second wave. We wouldn't finish the second wave until we get to 48 though. See 24 times 2? That would put us right here, that's at 48, but it's saying that we only have 42 of pipe. We're missing that last 6. So here, we could even count it out. 6, 12, 18, 24. There's my one wavelength. 30, 36, 42, bingo, 48. Maybe that thought process will help you out too. Okay, well that's about it. I hope everything goes well. And you guys can hit me up with questions when I see you next.